Here is step 6 of 8 for our chapter 2 ladder review. Here we're going to be analyzing some rational functions. So the first question asks us to factor f of x, and so if I look at the top here, x squared minus 16, that's a difference of squares. So I really have x minus 4 and x plus 4. On the bottom, I can factor out a 4 from each of these. And when I do that, and I'm actually going to show that up here so it makes this a little bit clearer. I can take out a 4, and then I'd have x squared minus 3x minus 4. So that's going to give us negative 4 and positive 1. X minus 4 and x positive 1. Okay, and then when I'm looking at this, so that's factoring, and I'm going to say, just for the sake of simplifying, just note that the x minus 4s, those factors cancel, and I would be left with x plus 4 over 4 times plus 1. So when I look at the domain of this, I'm going to say, well, I know that there's a vertical asymptote at negative 1. So for my domain, I'm looking at this and saying, I can go out to negative infinity all the way up to negative 1. But we also have to look back at the original here. Because of this crossing out on top and bottom, I have a hole at when x equals 4. And so because of that, and so that might be a little unclear. So when I look at the graph here, so this is our function, and I plug that in here just so you can see that that's what I put in. I graph it, and if I try to trace this and plug in a value of 4, there's nothing for y. So that means that there is a hole. It is undefined at that point. So for our domain, we would have to say that negative 1, and I'll put a little union here, negative 1 goes up to 4, but it doesn't actually touch it. We don't actually get to 4, and then from 4 to positive infinity. Okay, and so again, because up here I can cancel out these x minus 4 factors, I do have a hole, and that hole is at the coordinate point 4, 0. There's a hole there. And for our vertical asymptote, is at x equals negative 1, because that is the value that would make our function go to 0 in the denominator. If I want to find the y-intercept, is where plug in 0 into this function for x is the output, and that turns out to be 0, 1. And I'll show that again on my graph here. If I plug in the number 0, I want to know when x is 0, and I press enter, I get y equals 1. So my y-intercept here is 0, 1. Now it says find the x-intercepts. Well, the x-intercepts are where the numerator of our rational function, where those would go to 0. So if I put in a negative 4 in here, I would get negative 4 plus 4 is 0. So our x-intercept is at negative 4, 0. And we do not have one. Some people are going to say, well, if I look at the original, though, I had this x minus 4, so there's got to be an x-intercept at 4. No, that's not the case. Again, because of this canceling, there is a hole here. Find the horizontal asymptote, and the horizontal asymptote is we're going to get that because if I look at my function here, I have x squared on top, x squared on bottom, and because the degrees of the top and bottom are the same, I can take, there's technically a 1 right here, an invisible 1, I can take the ratio of the coefficients. So the horizontal asymptote is going to be 1/4. So horizontal asymptote y equals 1/4. Very close. It's going to look like on your graph that it's going to 0, but it's not. So just keep that in mind. So then if I sketch this, I have a bunch of these points that I already figured out. I know that I have a hole at 4. I know I hit the y-intercept at 0, 1. I have an x-intercept at -4. And again, we can use a graph here to help us sketch this a little bit. And basically, we're going to have that this starts to go this way. This goes downward. Again, it's a sketch. It's not going to be perfect. And actually, I should have had this probably going more hours here, so it's closer to -1. But you get the idea. They'd be infinitely close to -1, but not quite. So I should have had that come out more this way. And then going down here. Okay. And I apologize, that's a little messy there. Again, I just want to restate that this should be going down towards -infinity as we get closer to this vertical asymptote at x equals -1. For number 2, it says find the oblique asymptote of the following function. To do that, we're going to need to do some long division. So I'm going to have this set up here. So we're taking x cubed minus x squared minus 6x and dividing that by 4x squared plus 8x minus 12. And so what we'll do is we'll say, what would I have to multiply 4x squared by to get x cubed? Well, I'd have to multiply by 1/4, so I get 1, and by x to get x cubed. So we're going to say I would have to multiply by 1/4x. And as long division goes, we're going to end up subtracting some stuff. 1/4 x times 4x squared is x cubed. X times 1/4 x is what? 2x squared. And then -12 times 1/4 x is -3x. After I get done with some subtraction here, these cancel out. I get -3x squared minus 3x. And then playing the same game here, I'm going to say, what would I have to multiply 4x squared by -3x squared? Well, I'd have to multiply it by -3/4. Now, for getting oblique asymptotes, I technically could go a little bit farther and show that there is some remainder here, but once I've gotten to my constant in long division, this is going to be the answer, and and whatever's the remainder for the purpose of oblique asymptotes, we don't need the remainder, we just need this piece right here. So the oblique asymptote is going to be at y equals, or f of x equals 1/4 x minus 3/4.